In this tutorial, we're going to take a look at uniform probability distributions, and we're going to start with an example. And the first one, we have a spinner with equal size area red, green, yellow, and brown areas. Is used in a game, and you're asked to create a probability distribution, so it means basically list all the outcomes and their associated probabilities for the spinner. And so we would put the colors in first. So the colors are green, brown, red, and yellow. And it says you get a point for green, 1 point for green, 2 for brown, 3 for red, and 4 for yellow. So we put those in the table. You need some kind of a numerical value in order to make it a true probability distribution and to be able to calculate an expected value. So here's the all the outcomes with their values, and so since these are all equal in area and there's 4 of them, each one would have a probability of 1 chance at 4, or 1/4. And so we'll put the quarters on here. And so we're going to calculate the expected value. And so to calculate the expected value, we take each outcome and multiply it by its probability. So 1 times a quarter plus 2 times a quarter, and then plus the 3 times a quarter, and then plus 4 times a quarter. So 1 times a quarter is a quarter. 2 times a quarter would be 2 quarters. I'm not going to bother reduce because in order to add these, I want a common denominator anyway. 3 times a quarter would be 3 quarters. Remember, this is actually 3 over 1. So 3 times 1 in the numerator is 3. 1 times 4 is 4 in the denominator. This 4 is 4 over 1. So 4 times 1 is 4 on top. 1 times 4 is 4 on the bottom. And so if I add these, 4 and 3 is 7, 8, 9, 10. So we get 10 quarters, which divides out to about 2.5. Actually, not about, it's exactly 2.5. So that's the expected number of points for the game. So you would expect on average to get about 2.5 points on average. So you notice it's kind of between the two middle ones here. This is what the probability histogram looks like, and the reason this is called a uniform distribution is because all the probabilities are the same. Notice that there are 4 areas and the probability is 1 over 4. There's 4 bars here, and the probabilities are all 0.25. So for a uniform probability distribution, all the bars are the same height because all the probabilities are the same. Notice also that there are 4 outcomes, so it's 1 over 4. If there were 10 areas in the spinner, it would be 1 over 10 for each probability. So that's some of the characteristics of a uniform probability distribution. So all the outcomes have to be equal. Now, one thing I want to show you before we move on to the other example is the 1/4 is in all of these probabilities, so that can actually be factored out. And if we factor that out, then it would be multiplied by 1 plus 2 plus 3 plus 4. So notice that that actually is the sum of all the outcomes. 1, 2, 3, and 4, all the points. So we could write this as 1/4 times the sum of all the outcomes. Now, another way to write it, and you'll see this in some textbooks, is it's the 1 over 4 probability times the sum of all the outcomes. And this actually is the Greek letter sigma, the capital letter Greek letter sigma. And so it stands for the sum of a series. And so if k is 1, then the first number in the series is 1, which is this one here. And then this is actually, k is just a counter. It goes 1 up to 2, and then 3, and then 4. It stops at 4. The upper limit on the summation notation is 4. And so if k is 1, we get this term. If k is 2, we get this term. If the next number would be 3, counting is 3, and the last number is 4. So that's how that summation actually represents this series 1 plus 2 plus 3 plus 4. So when you see this, that's all that means. The summation is actually just the sum of all the outcomes from the probability distribution. Now, so again, a uniform probability distribution has the probability of every outcome being the same. So if there are n outcomes, then the chance of each one is 1 over n. And in the last example here in this uniform note or tutorial, we've got this game that uses a standard 6-sided dice. And if you roll an even number, you lose twice the number of roll in dollars. if you roll an odd number, odd is how you win $1 more than whatever you roll. And so we're asked to write probability distribution and calculate expected value. And then you're asked, is this a fair game? And I'll talk about what a fair game is in a moment. So first of all, the possible rolls are 1, 2, 3, 4, 5, and 6. Now, so all the outcomes, I'll put all these in here. So if you roll an even number, you lose twice that value in dollars. So an even number, for example, is 2. So twice 2 would be 4. So that's why there's a -4 here. The negative means you've lost $4. Double 4 is 8, so you lose $8. If you roll a 6, 6 times 2 is 12, you're going to lose $12. So if you roll an odd number, you win $1 more than that. So 1 is odd. So 1 more than 1 would be 2. You win $2 if you roll a 1. If you roll the 3, you get 4. So again, this is $1 more than your roll. And you get $6 if you roll a 5. 1, of course, 6 being 1 more than 5. Now, this is a uniform probability distribution because all the probabilities would be 1 chance in 6. Because it's just a normal, we're assuming it's a fair 6-sided die. So to calculate the expected value, we take each of the outcomes, not the rolls, each of the possible monetary outcomes here, and multiply them by 1/6. So 2 times 1/6 first, and then plus -4 times 1/6, and plus 4 times 1/6, and then plus -8 times 1/6, and then 6 times 1/6, and then the last one is when you lose $12. Times. You don't want to roll a 6 when you're playing this game. That's how you lose the most money. So if we multiply all this out, 2 times 1/6 would be 2/6. 2/1/6 is 2/6. -4 times 1 is -4, so it'd be -4 over 6. 4 times 1/6 is 4 over 6. -8 times 1/6 would be -8 over 6. 6 times 1/6 would be 6 over 6. Don't bother reducing them because now we have common denominators. And -12 times 1 would be -12, of course, over 6. So if you add all this up, and actually notice that the -4 and 4 add to 0, so that adds to 0 right there. And this 2 and this 6 add to 8, so they would actually add to 0 with the -8, 6. So that's why the expected value is actually -12 over 6, which equals -2. If you divide that, you get -2. So on average, you should expect to lose, on average, if you play this a lot of times, $2 per game. That's what that expected value represents. So this is not a fair game. A fair game is when your expected value, winnings, whatever it is 0. Okay? So for example, when you go into a casino, you're probably expecting those games not to be fair. The casino, if they were fair, then in the long run they wouldn't be making any money. That they're in business to make money. So those are not fair games because on average the casino wins. So that's what a fair game means. A fair game is when the expected value would equal 0. And that's the end of the tutorial.